This is going to be a presentation on stupid Raspberry Pi tricks. So this is kind of a recycled presentation from one that I did a few years ago. And I realized how old it was when I brought it up and realized that it was only talking about Raspberry Pi 1. So I updated it really quick this afternoon. Hopefully I don't find anything too horribly wrong in it, and hopefully you guys will enjoy it anyway. So just a little bit about, why I'm interested in the Raspberry Pi and kind of the experience I have on it. I'm actually a contributor to the Raspberry Pi project. I have code in the Raspberry Pi Linux kernel that's been upstreamed to the main Linux kernel and is also in the Raspberry Pi. And so I've been dealing with the Raspberry Pi since the Raspberry Pi 1 first came out. In my drawer here, I've got probably examples of every Raspberry Pi that they've had. And most of that is doing stuff with ham radio in one way, shape, or form. So a lot of this presentation is just going to be a quick overview of what the Raspberry Pi is for those of you that have been living under a rock for the past 10 years, and what the current state of the art is. And then I'm going to go over a few projects and stuff that I've done with the Raspberry Pi that's interesting with regard to ham radio that may give you some ideas of some of the stuff that you guys can do with the Raspberry Pi. So what is the Raspberry Pi? This is if you've been living under a rock for the past 10 years. It's a low-cost single-board computer, and its original intention was to introduce computer science skills to school children. There's actually, every time you buy a Pi, all the profits get funneled into a nonprofit organization that is interested in teaching kids how to code. And the Raspberry Pi itself was created so that we could give kids a very low-cost platform of their own to plug a monitor and a keyboard into, and then have it all ready to go so that they could write code on it and have their own computer for very cheap. There's a bunch of generations and variants of the Raspberry Pi out there now. There's the original Raspberry Pi 1 through 4, and they get more and more powerful as you go on. The first ones are a single core ARM computer clocked at like 700 megahertz, all the way up to the, and then they started to be quad cores and they put better and more powerful chips on them, always keeping the price point of the entry-level one at $35. So Pis are $35. There's also what they call the Raspberry Pi compute modules, which are really interesting because they are designed to be a Raspberry Pi that's stripped down to just the processor, the CPU, the memory, and everything, the voltage regulators to run that. And they strip all the peripherals out of it. Why would they do something like stupid like that? Well, what it allows you to do is design your own daughter board that you can plug the Raspberry Pi into and use it as embedded applications. So for people like Flex Radio, if we were to want to build a new radio, we could use the Raspberry Pi as a CPU in that thing and drop it in there and make it go. People are doing that with a lot of different stuff that you may or may not know a Raspberry Pi is actually inside of it. The first ones were kind of cool because they looked like an SO DIMM that plugs into a memory socket. So you just use a standard memory socket and then you could plug it in like an SO DIMM. It wasn't the same pin out as memory, obviously, but it was just a convenient connector that they could use. So that's kind of a cool thing that you can get. There's also the Raspberry Pi Zero, which has been pretty popular in amateur radio. And that's because it's a Pi that's very small, relatively cheap, but they strip a bunch of the peripherals off of it, like the big USB ports on it, and the Ethernet connection. It has no Ethernet. It only has wireless on it. So you can put it in really small places without a lot of wires going into it, power it off of a battery, and do some really cool stuff with it. So you see there's some projects that are doing like rotor controllers using this, where you can just, slam the thing up on a tower, provide it 12 volts or whatever, and then have the wireless connect the control back to the shack over the network. And one of the newer Raspberry Pis out there is called a Raspberry Pi Pico. that's designed to be an embedded system. So when you think Raspberry Pi Pico, think Arduino. It's really the Raspberry Pi Foundation's answer to the Arduino. A Raspberry Pi Pico costs $5. That's all it costs for the whole board, ready to go, ready to program. It's got flash memory on it and everything. Unlike Arduino's, it's actually a dual core ARM. So you've got two CPUs hanging out on this thing that you can do for $5. It runs an embedded version of Python, so it's actually not that hard to program either. So doing little embedded things, it's actually pretty cool. They came out with a new one that's called the Raspberry Pi Pico W that actually has a wireless interface on it. So if you need small embedded things that you need a wireless connection to a network to, I think the price on the W's is like $7. So you can get a tiny little embedded system for under $10 that will do that for you. It's kind of cool because it's called castellated. So it's designed so you can not only use it outside of a project, but it also, the PC board is designed so it can be soldered down as a component as well. And the Pi Foundation for embedded people that are actually putting this into products is also selling the chips for it. The Pi Foundation designed the chips on their own. So they're their own microprocessor that they're using. So kind of a cool new thing out there. I've got 4 or 5 of them hanging around that I'm playing with for different projects. So the current state of the art in normal human Raspberry Pis is the Raspberry Pi 4. And it's a Broadcom CPU on there. They're all Broadcom CPUs. The model number is 2711 on these. It's a quad 64-bit ARM processor clocked at 1.5 gigahertz apiece. So actually pretty fast for what you get, and some relatively powerful processors on there. And you can get 1 to 8 gigabytes of RAM depending on the configuration you order. So the $35 one is 1 gigabyte of RAM, and they range up to around, I think the 8 gig is like $75 if you want an 8 gig one. You would be amazed at what you could do with 1 gig of RAM for typical sort of use cases on these things. And it also has an SD card reader in it. That's generally where you will boot the thing where the operating system hangs out and stuff like that, all your storage. And it takes, I don't think there's a limit that I can think of on the SD cards. I've used 64 gig SD cards in them without a problem. It's also got a whole bunch of cool I/O ports. So it's got 2 USB 3.0 ports and 2 USB 2.0 ports that you can use. It's got gigabit Ethernet on it now. And unlike past Pis, the Pi 4 has the gigabit Ethernet hooked up to the PCIe, so you can actually get a gigabit out of it, which is nice. It's got 2 HDMI ports on the Pi 4, so you can actually run 2 monitors off of it if you'd like to. It's got a 3.5 millimeter audio out for sound, but note that there's no audio in on a Raspberry Pi. There's no microphone connector. There's no way to get audio into the thing without a separate sort of peripheral to do so. So for ham radio applications, that can be a problem because, for something like FT8, we generally want both input and output to it. Otherwise, it's not very much fun. Without the input, you can't receive. You can only transmit. One of the nice things about it is that it takes 5 volts in via a standard USB-C connector, so you can use a phone charger to power it. Most of them will work for just fine. And it's about at maximum going, as hard as it can, using all the compute power. It's about 1.2 amps, so 1200 milliamps. It's about 6 watts at full bore. So there are guys that are actually powering these things via solar cells and things like that, so that they can use them in remote locations and not have to worry about power. There are folks putting lithium polymer batteries on them in order to battery back them because they just don't take that much power. You do need a USB power supply that that doesn't droop in voltage a lot when it comes under load. So some of the cheaper Chinese USB power bricks will do that, and the Pi will brown out a little bit, which presents some of the problems there. I accomplish this in a little bit different way that I'll talk to you about a little bit later. The really cool thing about the Pi is that there's a whole bunch of low-level interfaces to it, the fun bits. So it's got 17 GPIO pins. That's general purpose IO. That's for digital inputs and outputs. They're good for things like turning on switches or flipping relays if you want to put a relay circuit on it or something like that. Or figuring out whether a switch is on or off. That's a general purpose input sort of thing. And they're flexible so that you can change them to be either inputs or outputs for all 17 of those pins. And they're on actually, I think I forgot to update this. There are more than 17 GPIOs on the new ones. This is for the original version of it. I would have to look up, but there's a bunch of GPIO pins on there. I'm sorry. Some of the pins on there can actually be used for alternate uses for different standard interfaces. So this is kind of technical. I2C is a standard interface for connecting things like analog to digital converters or extra GPIOs or other sorts of devices like that to it. A UART's a serial port. It's got a couple of serial ports on there. So if you need to talk to a TNC, there's a serial port to talk to a TNC or other sorts of equipment. Maybe you want to program, you have a Raspberry Pi that can program all of your VHF rigs. You can have the serial port so it'll talk to your Kenwood rig over the serial port. And do that. SPI is another lower level interface that you can put things like flash memory, ADC converters, things like that. PWM, it's as a PWM pin, which is for pulse width modulation. So that's used for doing different modulation techniques, things like doing variable load AC and things like that you can do with PWM pins. All of this fun is $35, so relatively cheap to get into this and do things, enough that it becomes kind of like a disposable computer that, usually because I'm crazy, my policy is I try and have at least one on the shelf ready to go at all times so that if I come up with some crazy project, I can yank it off the shelf and go. But does it run Windows? This is a favorite comic of mine. The real answer is kinda, but you won't like it. So just don't do it. Here's a nickel kid, get yourself a better computer, a better operating system. So yes, I am a condescending Unix user. So if you are going to run a Raspberry Pi, yes, you can run Windows on it. There are really lame versions of Windows you can run on it. There is the only officially supported one is Windows IoT for Internet of Things. You will not get a graphical interface on that. It is designed for stupid devices and is way stripped down. There are some crazy bastards that have gotten Windows 10 to run on it. But you do a lot of work, and guess what? It doesn't really run very fast, any Intel stuff, because it has to run the Intel stuff all in emulation. If you got any device drivers, those won't work on it. So I'm biased, but I would tell you that you really would like to learn Linux if you are going to embark on a Raspberry Pi journey. That's just the way it is. There is lots of cool Linux software out there to get going on this stuff, though. Let's talk about some ham specific accessories that are out there that are kind of interesting. There's something called a TNC Pi. If anybody knows about the TNC-X TNC, it is a TNC chip that's interfaced to the Raspberry Pi over one of the serial ports, has all the PTT ready to go and everything on there, so that you can use it to hook to the radio and go. So it's a self-contained TNC.
Hey, Anna, I think Scott's trying to show you something there. I think he's got something related to what you're talking about.
Yep. And the picture on the right is two TNC Pis stacked up together on my slide. So they're actually set up so that you can stack them and have a couple of them on there. There's also some GMSK daughter boards out there that will run GMSK for decoding D-Star. So they call them node adapters sometimes or something like that. They're a little bit older and a little bit harder to find these days if that's what you're looking for. I also have a couple of boards that implement a whisper beacon Essentially, they use the PWM pin to do modulation and put a whole bunch of filtering on it. And there's a little daughter board that drops on the top. I think they're put out by Tapper, TAPR.org, and you can buy them for different bands. And I think when I got the 20-meter band one, it was like $10 or $15 for the board. You drop it on top and put an antenna on it. It's like 500 milliwatts and it's ready to go. So you can have a dedicated whisper beacon for real cheap. And one of the real interesting ones that's out now that everybody's really getting excited about is the MMDVM. It's called a multi-mode digital voice modem. And it's it was put out by Jonathan Naylor, came up with the design. He's a guy in England. And it will do either D-Star or System Fusion for Yaesu, or it will do DMR. And it will automatically switch in between them. And it's a universal modem for that. What a lot of folks use it for is to create a little local hotspot at their house, so that they can have a little, just a hotspot so they can run with their handheld around the house and get into all the internet reflectors using their handheld. So it kind of provides a little local simplex repeater, digital repeater for folks. There are also some folks, myself included, that have made whole repeater systems around an MMDVM. So you can use that to create a whole digital repeater as well. Ross in Eugene, that runs the multi-mode repeater there, that is an MMDVM hooked up to it. I believe it's running on a Raspberry Pi, but I'm not sure. So you can make whole repeater systems out of a daughter board with an MMDVM and a Raspberry Pi. And here is the shameless plug that you will get from this. I am a partner in Northwest Digital Radio. So we're a company that originally we made some USB keys to decode D-Star on the internet. One of the other things we got interested in was the Raspberry Pi pretty early, and we came up with this board called the Draws board, which is kind of like a ham radio, Ginsu knife. It slices, it dices, it makes julienne fries. So this is where I did the work in the Raspberry Pi kernel in order to support a lot of the hardware on here and made the contributions for that. So it is a sound card with two DIN6 connectors on it that's pinned out like a packet interface on your radio. So you can use a straight through DIN6 connection to hook to a packet radio interface on up to 2 radios on this thing. So you can use up to 2 radios at once. It also has a GPS with a pulse per second pin pinned into the Raspberry Pi. It's on its own serial port, so it doesn't burn one of the Pi serial ports either. And that allows you to have a high precision Stratum 1 time server on it. That which is useful for doing the APRS and things like that, or doing FT8, where you want to have accurate time on there. Also, since it's the GPS, you can get positioning off of that as well. So if you were to use a Raspberry Pi in your car with one of these, you can put a GPS antenna on the top and then use it as a small tracker. We also have a 12-volt power supply that back powers the Raspberry Pi itself. So you can put 12 volts onto the Draws board and it will power your whole Raspberry Pi setup off of 12 volts. And it's not just 12 volts. I think we've got it set up that it ranges anywhere from 9 to 18 or something like that. So it's a little bit larger range than just 12 volts. And as I mentioned earlier, this is how I do most of my Pi's power supplies when I use them in amateur radio uses. And there's a link to it. It's nwdigitalradio.com. If you have questions on it, I can tell you a lot. There's actually some folks that are running whatchamacallit. Now I just lost what it was, but yeah. Anyway, there's a lot of cool stuff you can do with it. One of the things I'm doing with it that I don't think I mentioned later in the presentation is I have a digipeater and iGate here in Lebanon. And the digipeater and iGate runs on a Raspberry Pi with one of these on top. It goes to a Tate commercial radio and sits on 144.39. I also have a second channel that goes to a second Tate radio that does 9600 baud packet, so it can gateway between 9600 baud and 1200 baud packet on the same box. I also use that as a time source for my entire shack. So my entire shack goes and looks at this thing because it's on GPS time. And it's within a few, milliseconds, nanoseconds of time. So it's pretty useful to have around the shack. So one of the first projects that I'm working on, but I don't have complete, that I've been dreaming about since I wrote this presentation 7 years ago, is a rotor controller based on the Raspberry Pi. I just got an alpha spid rotor. I was originally going to use a ham M for this, but it was too much of a pain in the rear. The alpha spid is 12 volt DC, so it's a lot easier to switch. So I've got a couple of prepackaged H bridges off of the internet that I'm going to hook to GPIO pins on the Raspberry Pi, and then I'm going to have a web interface on it using JSON RPC and Python, and I will be able to programmatically control my rotor from anywhere I want to using a web interface. Oops. So that's kind of some of the interface components on there. You can see where I actually have put in there the beam width of the beam that I'm using, and where I am on Earth, and I got a great circle map of it. Then I put degrees and turn the rotor and things like that. So I have some code that I've written for it. I had it kind of working, but not really working as much as I'd like. I'm currently working on some possible improvements, which is using a magnetometer for the detection of the beam heading, so that I don't have to use the pulses off of the rotor or a cruddy resistor or something like that. What I really want to know is where that beam is pointed, and now we have cheap sensors to do that. I bought an Adafruit sensor for like $10. That's got a magnetometer and accelerometer on it, the whole 9 yards, so that I can ask it where it's pointed, and it'll tell me it's pointed, 57 degrees. So I'm going to put that up on the tower. I'm going to try and power it. It's going to go over Ethernet, and I'm going to try and power it with power over Ethernet so that I can have it up there all on one cable. I also thought about using GPS on it to determine the position for the map and time if I needed to. So that would be a cool feature to have in it. Here's another project that I did that I talked about it a little bit. I got a T800 repeater that has two sides to it. It's got a 440 side and a 2-meter side. And I made a D-Star repeater and APRS digipeater out of it. It's intended to, it was intended because I had a local ham in the area when I first came back into the area from Massachusetts going to law school, that told me that he would never, ever, ever allow a computer up on a repeater site because they suck and they always break and they're just evil. So if I had a repeater that required a computer, then that was a no-go for him. So part of this whole project was to deceive this particular ham by putting the computer inside where he wouldn't see it, and it looks just like a regular repeater. You can see the picture on the right is the front half of the repeater. When you look at it, you don't see a Raspberry Pi anywhere in there. So in here, this is the older generation. I went through a couple of generations of this thing. There's a Pi that fits in the back, in that center behind that center speaker panel, with a TNCX and a GMSK node adapter, which will speak D-Star behind the speaker panel. I actually had it so that I was doing a draws board to use a software TNC modem for the packet side, and doing an MMDVM for the D-Star side. Everything runs off of 12 volts. So you run 12 volts into it, everything's good to go. So you can kind of see that is what is in back of for the first generation, that was what was in back of the speaker panel in there. You can kind of see how it fits in the chassis there. And that's kind of what it looks like when it's all put together. So unless you really know what you're looking at, I can call it a repeater controller, and that's not too far from the truth, and nobody really knows that there's a little computer inside. Possible improvements that
very sleuthy and a very sleuthy.
I do what I can, I hate people doing irrational things. So, part of it is just to say that I can do it. But anyway, that never made it up on a site because I never found a site. In fact, if anybody is interested in that, I have somebody kicking the tires, but I'm selling the latest generation of that repeater for $500. So if anybody is interested in having a repeater like that, that's pretty well set up, I'm happy to talk to them about it. So I, in fact, did use Direwolf rather than the hacked up TNCX. Why, you might ask? Direwolf is actually a lot better packet modem than the TNCX is. And here is one of the big reasons why. Because we have so much CPU power, we can actually run the samples that we get through multiple different algorithms to try and decode them, and then pick the best one at the end. Whereas a TNCX only has one algorithm to use, and you either get it or you don't. So there's a lot of power in using software to do that rather than hardware. And you can see in the testing, you can go on to the website for Direwolf and see the results of how much more you decode using a software modem these days. So I switched to that just because of that fact. And it's better GMSK. I want to get better GMSK decoding in there, which I did with using the MMDVM. It does a lot better at the GMSK decoding. There you go, MMDVM instead of a node adapter. A future project that I thought of was creating a portable analog repeater that I could throw in the car and have ready to go and deploy in an emergency situation or field day or whatever, where I could use the Northwest Digital Radio draws on a Raspberry Pi, a couple of surplus Kenwood TK705Ds I have for the RF deck, 802.11 wireless or a cellular modem to connect to the internet so that I could do Echolink or IRLP or All Starlink or whatever I wanted to do over internet linking, and potentially have just use the PC repeater controller, although there are better pieces of software that I'd probably use out there these days. So kind of an idea project about how you could break a really, really compact little box with a Raspberry Pi as the repeater controller in it, and then go for it from there. Project number 3 that's in my shack, ham clock. There's this really, really cool, and these tricks get stupider as we go along. So there's this really, really cool project called Ham Clock that looks like this picture in here, where it will give you time off of GPS time and display on the front panel. I used a partially destroyed 7-inch Raspberry Pi touchscreen that I had for this thing that still looks okay, but the touchscreen doesn't work so well on it, to display this ham clock that just sits there. I needed a station clock, but I didn't really want to spend the $700 or $800 for a Geochron. Even their, new one that you combined with your own monitor is like hella expensive. So I used this as a way to create something a lot cheaper. And it was used to spare stuff I had hanging around. So a 7-inch touchscreen. And there's the website where you can get the ham clock. They've got directions on there on how to set it up on a Raspberry Pi and how to do it. I locked it down, so that's basically all it does. And I have a Raspberry Pi that's just a clock. It shows nice things like sunspot numbers, and I've got it showing satellite passes, so I always know when the ISS is coming over. Not that I do satellite, but I kind of like to know when the satellites come over just for fun. I didn't change the picture out on that one. This is a really stupid Raspberry Pi trick. My wife bought me a commercial on-air sign from a TV station a while ago for Christmas because she thought it would be cute. And it was. I really loved it. Supposedly the provenance of it is that it came from the Austin City Limits studio at the University of Texas. So there is that. And I was trying to figure out what I was going to do with it rather than just having this, sign that I could turn on and off. I retrofitted it with LED lights to make it a little bit more efficient and brighter. And I put a Raspberry Pi inside so that I could trigger the LED lights with a GPIO on the Raspberry Pi. And I wrote a program that logs into my Flex Radio 6600M and watches for when the 6600 goes into transmit. And then it lights the light when the 6600 goes into transmit. And because the 6600 is an Ethernet device, it can just go and log in and sit there and listen to all the events that are happening and subscribe to them, and then do whatever it wants on it. You would like to see that? It's written in Python. It's open source. You can go onto my GitHub site and download it and play with it to your heart's content for those of you that are rich enough to have Flex radios. Some pitfalls of the Pi that are kind of sucky. X Windows and VNC are kind of cruddy. So if you are somebody that has to click on things in order to make computers work, the Pi for all these embedded applications may not be for you, because doing that remote is kind of hard sometimes. There are a lot more tutorials out there for it now. I'm kind of a hardcore Unix head and believe that if you have a head on most of this stuff and graphics that you've lost. So most of my stuff I can manage over SSH on the command line. So the power budget can kind of be tight on it as far as how much power it can supply over the USB ports and things like that. So that can be a little bit limiting sometimes. The software is always evolving. It's a lot better now than it's been ever before, but there's still some rough edges out there that you'll run into with the software. After all, it's all open source and nobody's really paying anybody to do any of the Raspberry Pi stuff, so you kind of get what people give you. And as I mentioned before, there's no native mic or line-in audio, so you're going to have to come up with some other way of getting that in. Some people use USB cards. There are quite a few sound interfaces out there. There's the Northwest Digital Radio DRAWS card that you can use to get mic in and things like that. And a big one is there's no real-time clock on a Raspberry Pi. So when you shut it down and turn it back on, it has no idea of what time it is. There are hacks that get it really close, but it will start losing time if you don't have a way to get its time, either by using NTP over the internet or having some sort of GPS locked on there that will update its time when it goes on there.
I'm surprised at that, Anna. I thought that, a simple, CR2032 battery, a watch battery, would keep something alive.
Nope.
But no, nothing.
No, there's no battery on there, and I would imagine that's on purpose. That way they don't have to ship batteries with it to do anything like that. And batteries are kind of a pain in the rear. So what some people do is
disposal issues.
there are RTCs that you can plug onto it, because you can use the I2C interface to do RTCs. Some of them have batteries, but believe it or not, some of them just have a huge supercapacitor on them. And they have a supercapacitor that'll run that I2C chip for a month or two. And that's usually all you need. For the DRAWS board, we actually have a battery on it. That battery backs up the GPS unit, and the GPS will keep time in it, so that even if it's not seeing GPS signal, it has an idea of what time it is, and it will provide that to the Raspberry Pi that you can pull off of it. So that's part of how we solve that problem. So
one of the things, Annaliese, that when I started working with Raspberry Pi that was annoying to me was that I have it plugged in, still plugged into one of the ports on my monitor, and I'm having to switch back and forth. So I solved that by doing a remote desktop into the Raspberry Pi, and then since I also with Linux usually just use the terminal interface, I just start the terminal on it, and that works quite well, because now I've got it in a window on my PC.
I just use I use the light version of Raspbian most of the time, so there's not even any graphics on there. It's just command line on the console, and I use SSH to manage everything. And in fact, there's a special, if you put a file, when you first set up the Raspberry Pi, if you mount up the FAT partition and you make a file named SSH on it, it will start the SSH server by default when you bring it up. So then you don't have to have a console at all. You just figure out what IP address it got and SSH into it, and you're ready to go. So you don't even need to hook a monitor up to it ever.
And the modern, or the most recent version of their SD card flashing utility, that's a checkbox to enable SSH.
Yeah, I haven't used that yet. I use Balena Etcher, so yeah, that's kind of what I do. Anyway, advanced usages that probably aren't of interest to you guys. So, but you can. I guess one of the good things about that is most all of the source code for the Raspberry Pi is out there in the open and available to you. So much so that I have actually created my own variants of Raspbian off of there and made my own images. There are also images, ham radio images out there. They're targeted towards different things. One of the ones I can think of is Pi Star. So going and creating one of these hotspots that I was talking about, you can get a load called PyStar where you can burn an SD card off of it. And it's got everything you need on there all ready to go with a nice setup function on it and stuff like that. So that's a nice thing about it. The boot blocks are closed source because of some NDAs with Broadcom, but almost everything else that I can think of is all open source on this. So you can take it apart and play with it. So I just wanted to quickly go over alternatives to the Raspberry Pi because there are a few out there. The Odroid series was really popular for a while because they had more, some bigger processors on there than the Raspberry Pi, some more capabilities. A lot of folks liked it. PC Duino, which is kind of a mixture of the Arduino and having a full computer on there. BeagleBoard is not quite as popular anymore, but was really popular at one point in time, again, as an alternative. There's a whole bunch of USB stick computers out there that are pretty interesting and low power. There's a one called the Banana Pi out there that has a different software load on it that people can go. And the Pine 64 is also mildly popular out there. The one thing that I would say about these alternatives is that you get a lot of hams that go off on trying to get all of these alternatives so that they can get the higher performance single board computer and go crazy with that, to which I ask them, do you really need all that performance? The answer is usually no for the application they want to do. And they're paying like 95 to $100 for a single board computer rather than 35. So you got to ask yourself whether that additional performance is really worth it to you. The answer may be yes. And if it is, then that's great. The other thing you have to consider is the number of people working on that platform as well. One of the great things about the Raspberry Pi is there are literally millions of people contributing crazy stuff to the Raspberry Pi that you can do, that you can download and use and make work. Whereas if you go with a Pine 64, the user community is much, much, much smaller. You're going to find a lot fewer hams using it, and you're not going to get as much support as if you go with Raspberry Pi. So those are just some trade-offs about going with some of the alternatives. And that's about all I've got for today. Hopefully I didn't blather on too much and bore you guys, but hopefully it's been a little bit educational about the Raspberry Pi and single board computers out there. I find them very useful for a lot of dedicated embedded applications where you don't necessarily want to put a full PC in there just to be a digipeater, taking up all the, making noise and taking up all the power and things like that. You can have something that's small, low power, and relatively cheap to do that for you. And that makes it really easy to afford a lot of these automated things that are happening, like putting up your own digipeater or putting up your own hotspot. We also have some people that are having a good time using them for emergency communications workstations, right? Because they're relatively cheap. You throw a monitor on them, you can set a set load on them, mount them on the back of a monitor, and they're ready to go. Another application that's interesting is for the Willamette Valley mesh network that we've got going in the Willamette Valley. There's a PBX system on there. And we in Linn County have a PBX online that is implemented in a Raspberry Pi that sits on that network. So it sits there without a monitor, just sits there and runs, and we run it via web interface and SSH, and it's crammed into the corner of our emergency trailer here in Lebanon at the Lebanon Hospital, and it just sits there and runs. So anyway, I will stop talking and let somebody else talk if they have questions or comments.
Yeah, this was fabulous. I literally have been just I've heard the word Raspberry Pi. I remember when the first one came out, I was at Dayton, and I actually I think I was at an IBM conference, and they actually gave one away to inspire IoT, which is Internet of Things, right? So so they were inspiring, some creativity and some real-time, data collection and other things, and showing it up on a real-time graph. And of course, it wasn't ham related, but the point is they were inspiring, much like you said, computer science and engineering folks to get into the more depths of the possibilities of what this had to offer. So this is great. Thank you so much.
The Pi is a lot more heavyweight for people that like to have the safety net of operating systems under them and all the tools that brings along. So there are a lot of people that are fans of the Arduino. I am not. I don't think there's many, to me, there's not very many advantages. Power consumption is one of them. I don't believe that price anymore is really one of them, because by the time you make an Arduino do something useful, you've added so many so many shields on it that you've driven up the price that you might as well just bought in a Pi. So, but I'm biased, right? I'm an operating systems girl. I don't like little embedded stuff. And in fact, my snide comment is that I feel like Arduino and amateur radio comes down to name that tune, right? How small can I get this application to go? And it just becomes an appendage measuring competition rather than anything useful.
I like the ESP32 for somewhere in between those two.
I just don't find many applications that I can't afford to spend $35 on, right? I mean,
yeah, the Raspberry Pi is, as you say, more than you need for a lot of things, and so I just look for something lighter and smaller. But I also have gripes about Broadcom and their NDA.
yeah,
the emotional side of things.
yeah. Hard to get away from these days as chip consolidation is happening.
Oh yeah.
Anybody else?
So I've got, so if I can see if I can get it to, yeah, it's gonna take me longer to get that figured out. So I've got a Pi 4 4 gig with a PoE hat that I use nominally for I got it hooked up to an SDR in my shack, so then I can do some remote data collection off of the SDR in the shack, and that works out really well. And I've been really happy with the PoE hat there. And I've got a 128 gig SS or flash drive or SD card plugged into that one, and have managed to use almost none of it. And then also sitting on my next right next to me right now is also a Pi 3 that I had been playing with in that same role until I got the Pi 4 and replaced it, not because I needed to, but because I could.
Oh, I guess I should mention that's the other thing that I have the Digipeater doing. It has a RTL SDR plugged into it that goes to an antenna on the roof that I do the ADSB receiver on. So it makes a really good embedded system for that, because you just plug the USB key in. We actually thought at Northwest Digital Radio for a while about doing a voting repeater system with RTL SDRs, because you could put an RTL SDR and a Raspberry Pi in a place with just an antenna to get a receiver out of it, and then digitally run all that data back to some sort of controller in the middle that would decide which of the digital voting repeaters was best out there and pull them out. So interesting things that you could do using that sort of architecture as well. Anybody else?
Hey, can we get a copy of your presentation?
I don't know, Scott, not for you.
Yeah, yeah.
I should have taken pictures of the screen then.
Every time it moved, take a picture. Yeah, there we go.
I will try and remember to see if I can put a PDF up here somewhere soon.
Well, the good news is it's been recorded too, Scott, so you can always watch it in real
Oh,
time.
that's true. Okay, yeah.
But yeah, so the slide deck can be referenced.
Yeah, you can
So-
save a lot of time by bypassing all of my blathering and just looking at the slides, right? So, you know.
Your commentary.
No, Anna, thank you so much for sharing all of your wisdom on this particular topic. You can tell that you've done a deep dive into this in a number of directions with efficiencies and usefulness and applications. that was my one question. And I was glad I didn't raise my hand because I didn't know that there was more coming. Like, project 1, project 2, project 3. I was like, because my first question was like, what have you done with it? That's really cool. Right.
Mhm.
And I'm glad I just sat back. And so that was good.
Those would be the stupid Raspberry Pi tricks, right? I mean, say
Yeah.
they go from more, less stupid to more stupid, but I think the on-air sign is actually a pretty cool hack when you see it.
Yeah.
Very nice.
One thing I wanted to say to Anna was, I mentioned this to, I think to you before, Anna. We the LC High School has a tech class sort of. Since the semester just got underway, we're going to fire up, trying to get some students involved in projects. I think some of these Raspberry Pi concepts that you're talking about would be perfect.
Mhm.
So I'd like to talk to you more about it. I have to, get in touch with the teacher and
Sure.
talk to the kids and all that stuff, see what they would like to do. But this is definitely, maybe not necessarily any of your particular projects, but something along those lines I think they would be very interested in.
Well, and if they'd like,
Some-
a project advisor or somebody like that that can,
Yeah.
provide some assistance and help
Oh,
and
yeah.
guidance, then I
Much
might be able
better
to
than-
convince to do something for that.
Yeah, much better than I would be able to do. I just can physically be there, but definitely you'd be the brains behind it if it went that far.
Well, and I may be able to ask my boss for some time off to do that. There's another guy that's been able to do that, and I have a relatively flexible schedule, so
Okay.
I might be able to fit. No promises, but I might be able to fit something
Sure.
like that into my schedule. Getting kids and especially young ladies interested in this stuff is
Yes,
really
and there's
important to me.
a few young ladies.
Cool.
So I'll be out there tomorrow. So
Sometimes seeing an engineer more like them, helps out a little bit.
oh, that's what I was thinking too. But I figured, how are we going to get Anna out there? Okay. If that
I have
could
a
work.
car, Scott.
Well, I have a helicopter. I'll just fly him.
Yeah.
I know where Alcy is. I've driven through it a few times. I grew up in
Okay.
Corvallis.
Okay. All right.
All right, great. Well, thanks so much for throwing this together at the last minute. Anna, sorry you weren't feeling well. Glad you were able to update it at the last minute. Thank you everybody for hanging in there and listening and sitting at the foot of what I would call one of our resident experts, especially on this topic. And so this was great. And again, I inspire others to say, hey, what do I do that's really cool with the hobby, or what do I want to learn, and put together a couple of slides and just stick your neck out. It's really great experience. And it's great what chatter it offers afterwards, more questions and people offering suggestions, and it's very well appreciated, anybody who does this. So I encourage it.
Well, and if anybody has other topics that they know I'm familiar with that they'd like to know more about, then usually you can poke Mike and Mike can poke me, and I'm happy to put stuff together. I mean, y'all know me by now. I'm not afraid to talk your ear off. So.
So
Okay.
cool. Hey, Scott, before you go,
Yes.
can I give you a call right after this?
Yes, absolutely.
Okay, great. All right, I'm going to go ahead and